In this lesson, we will fully sketch and describe. First thing we do is look at the number of roots. We have 4 zeros, 4 minus 1, 3 turns, 3 minus 1, 2 inflection points. We notice that the coefficient is positive, so our end behaviors go up. Now, we find our zeros so that we're able to sketch. Set your y equal to 0 and factor. We factor out an x squared, and we're left with x squared plus x minus 12. We factor this again, and x plus 4, x minus 3. Set them all equal to 0. So you notice this is a double root at x is 0. This is your double. Multiplicity of 2, x is negative 4, x is 3. So if I were to graph this, I would put my double, my negative 4, my positive 3. I know my ends are going up, and I know I make a bounce off of this. Somewhere I'm doing this, and in my calculator I confirm that this one is a little bit longer than that one. So we're going to find we'll find your y-intercept as well. You need to find this algebraically. This is when x is 0. So notice when all of those are 0, then your y is also equal to 0. So let's call that point B. So let's find your absolute minimum point at A. This will also help you find your range for this function. So we put it in your calculator and we find your absolute min to be negative 2.853 and negative 54.644. We find B, your relative max, and we knew that at the 0, 0, that's where your roots were. And C is another min, but this one's your relative min, and you put this in your calculator, and you will find your values at your relative min. Now, we can do our increasing and our decreasing from here. Our increasing values are going from negative 2.853 to 0. We're increasing from A to B, and from C to infinity, 2.103 to infinity. Our decreasing values, negative infinity down to point A, negative 2.853, and one more decrease from 0 down to point C, 2.103. So we've got your increasing, decreasing. Your domain, again, is all real numbers. Your range, we found your absolute minimum point, so we are negative 54.644 to infinity. We did your increasing, decreasing. Now to find your inflection points, we need to look at your concavity. We've got a concave up and another concave up, and then in between we concave down. So from B to A, we share. We need a midpoint. From B to C, we share. We need a midpoint. The midpoints of these these parts of your curve, your function, are called your inflection points. So to find D, we're going to take the x value of A, your relative, your absolute minimum. So we're going to take your A, which is negative 2.853, plus the y, plus the x value of B, which was 0, and take half. So this becomes negative 1.427. You're going to put this in your calculator. Second calc, number 1, put your x value in, and let it return your y of negative 23.195. We're going to do the same thing for E. We're going to find the midpoint between B and C. So we're 0 plus 0.2103, take it divided by 2, and you get 1.052. Put it in your calc, find the y value. You just need the y value to find your inflection point. You don't need it for your concavity. So now we're going to concave up. Concave up from negative infinity to the x value of the D inflection point, negative 1.427. And we're going to concave up again from the x value of the E, 1.052, to infinity. We're going to concave down between them. So from negative 1.40 from 427 to 1.052. We're going to concave down. In the next sketch, we have three roots. Three roots, 3 minus 1, 2 turning points, 2 turns, 2 minus 1, 1 inflection point. We can see we have a positive coefficient, so my end behaviors say down on the left, up on the right. So let's find your zeros. Let's factor this. Take out an x. Factor it again. There's no multiplicities here. Everything is just a single root, and we expected to see 3 of them. So from our sketch, we can see where this is going. We know it's down and it's up. They're both coming through. Oops, my bad. Sorry, they're both coming through this way, and they've got to meet with this one in the middle. So you're going to come through and kind of sketch a curve. And we notice this probably dips a little bit more than we had anticipated. So we're going to call this max A, this min B, and we're going to go through and see where we are. Now, let's find your y-intercepts. Your y-intercept said let x equal 0. Notice when you plug the zeros in, y is equal to 0. Just show that to me algebraically. Your minimums and your max. Since this curve has a domain of all real numbers and a range of all real numbers, we have no absolute max. A would be our relative max. Make sure you tell me relative. And B would be our relative min. So we find our relative max. Use your calculator, 3 decimal places.
Zachary Williams, please.
And find your relative min. From here, we can do your increasing and decreasing. So we're going to increase from negative infinity to negative 5.23, and again from 3.189 to infinity. We're going to decrease from negative 0.523 to positive 3.189. Whoops, 3.189. Now, the only thing left is your inflection points. To find your inflection point, let's call it C, you have to take the average of the x's from point A to point B. So we take your A, we add it to the B, we divide it by 2. So your inflection point comes out to be 1333 for the x. Put it in your calc, do a calc value, and find your corresponding y. That's your inflection point. Your concave up goes from that point that you found to infinity, and your concave down goes from negative infinity to that point.